medians and altitudes. We're going to go ahead and get started. Remember, no phones out, no submitting assignments in class. Make sure they're in your backpack. All right. First thing we're going to learn about is a median. A median is a segment whose endpoints are vertex of a triangle and the midpoint of the opposite side. So if we're looking here, this dotted line, AE, this segment AE, this is the vertex. It's not a line, it's a segment. Starts at a vertex and ends at a midpoint, or vice versa. Same thing. So it's got to connect to a vertex and it's got to be the midpoint of the opposite side of that same vertex. So remember, we know this is the midpoint because they've marked BE congruent to CE. So we're about to learn about another segment in a triangle. So we're gonna reword that a little bit just for emphasis. So remember that a median bisects a side and starts at a vertex. So it has the start at a vertex and bisects a side. That means one endpoint is a median. A midpoint. All right, example 1. EG is a median of triangle DEF. So right now I'm thinking I gotta go ahead and mark these segments. It's split this side DF into two congruent segments. The question asks us to find X and if, and DF if DG equals 4 times X minus 1 and GF equals 2 times X plus 5. So DG from here to here is 4 times X minus 1 and GF from here to here is 2X plus 5. So we know that they're congruent, so now we can write our equation. Remember, this expression represents the measure or the length of DG. This represents the measure or the length of FG. So when we're talking about the measures, then we can set them equal to one another and solve. So I'm going to go ahead and do that. We're finding X. We don't have to find any lengths here. So I have variables on both sides. So I'm going to subtract this 2X from both sides. And now I have 2X minus 1 equals 5. I'm going to add 1 to both sides. So now I have 2X equals 6. And I'm going to divide both sides by 2. So now I know that X equals 3. If I wanted to find the length of DG or the length of DF, I could plug in 3 for X in these expressions. So remember, the important thing here is that it starts at a vertex and it is a bisector of the opposite side. And then altitude is also a segment, but this is not a bisector. It's a segment from a vertex and it's perpendicular to the other side. We could technically bisect the other side in some triangles, but that is not a defining characteristic. So this segment from here to here, or this length from here to here, is the altitude of triangle ABC. It starts at a vertex, goes to the opposite side, and it's perpendicular, which means this makes a right angle. So remember, we have to keep median and altitude separate. We're going to have a way to distinguish it. So a median is a bisector. An altitude is perpendicular to the opposite side. So an altitude must come from a vertex and be perpendicular to the opposite side. And it may be one of the sides of a right triangle, so you might see that sometimes. Example 2. In triangle JKL, KT is an altitude. So KT, so an altitude, it doesn't tell us this. We have to remember what an altitude is. An altitude starts at a vertex, this does, and because they told us it's an altitude, now we know this is a right angle and this is a right angle. So now we're looking at two right triangles. The question asks us to find the value of y if KTJ is 7y plus 6. Angle KTJ. So this is 7y plus 6. So this angle. So it says here, make sure you're paying attention because this is one thing that sometimes you guys miss. This is an angle, not one of the sides. So since this altitude is perpendicular, now we know that this angle has a measure of 90 degrees. If this expression also represents the measure of this angle, now we can set 7y plus 6 equal to 90 and solve for y. So we're going to subtract 6 from both sides. So 7y equals 84. Divide both sides by 7, and y equals 12. Alright. Remember, you can pause these videos anytime you want to write in things. So EG is a median of triangle DEF. Find X and DF if DG equals 2x plus 11 and GF equals x minus 4. Did I miss something back here? Okay, so we do, in example 1, we're going to go back to example 1. It said find X and DF. So we forgot to do that. So this is DF here. So we know that DF is equal to 4x minus 1 plus 2x plus 5, right? Because it's this segment plus this segment equals the whole thing from here to here. So make sure you're reading the directions. Don't skip any parts like I did. So now all we have to do is plug in x for 3. So now we know DF equals, why I put a 3 there, equals 4 times 3 minus 1 plus 2 times 3 plus 5. I'm going to do the multiplication first. 12 minus 1 plus 6 plus 5. So 12 minus 1 is 11 plus 11 is 22. So now we know that DF has a length of 22. And you could have just done one of the lengths, DG or GF, and then multiplied by 2 because they're the same length. Okay, going back to example 3. EG is a median of triangle DEF. So when I see median, I got to remember from a vertex, and it's a bisector. Let's say a bisector from a vertex. That's what a median is. So it starts at a vertex, so now I know it's bisecting this side. That means DG is congruent to GF. So we're going to find X and DF. If DG is 2x plus 11 and GF is 5x minus 4. So really the same thing. This segment's measure is equal to this segment's measure, so we're going to set them equal to one another and solve for x, and then we'll plug them in to find the length of DF. So I need to get x's on the same side. I'm going to subtract 2x from both sides. I'm going to add 4 to both sides. Divide both sides by 3. And now we know x is 5. And we can use x is 5 to find df. Well, I know df is the same as dg plus gf, but it's also the same as 2 times 2x plus l, or 2 times 5x minus 4. So that's what I'm going to do this time. I'm going to do df equals 2 times 2x plus 11. So 2 times 5 plus 11. So 2 times 10, 2 times 21 is 42. So you can see if you did it here, 5 times 5 is 25, minus 4 would also be 21. So either way, we could add them like we did the first example, but now we know df is 42. An example, JKL, KT is an altitude. So it's not a bisector. An altitude is from a vertex perpendicular to the opposite side. So the oppo side, not a bisector, but perpendicular means we create these two right angles here where it meets this side. So if we know that angle KTJ, remember this is an angle, not a side. KTJ, that's this angle here, which now we know is 90 degrees. So 4y plus 8, that's the same as 90 degrees. We're going to set them equal to one another. 4y plus 8 equals 90. Subtract 8 from both sides. 4y equals 82. And 82 divided by 4 is 20.5. Yeah. So y is 20.5. All right. And name the segment described below. So an altitude, so it's perpendicular, it's from a vertex and perpendicular to another side. So right now we're talking about triangle MQO. So M to Q to O. So we're talking about this triangle here. So an altitude, so it's got to come from a vertex and be perpendicular to a side, the opposite side. So in this case, the altitude is going to be one leg of the triangle, like we mentioned. So MQ is the altitude of triangle MQO. So MQP, let's see. Alright, let's just do MQP in a different color because I can't erase it. So triangle MQP. So MQP. So MQP, the altitude, remember, is from a vertex. So it's from this vertex to the opposite side and it's perpendicular. It's also going to be MQ. Now we're going to do a median from triangle MOR. So a median from triangle MOR. So MOR so it's the whole big one. MOR. So we want a median for MOR. So a median goes from a vertex to the midpoint of the opposite side. So it's this big purple one. So it's going to go from a vertex. So that's not a bisector. How about this segment here? It goes from angle R across to the other side, and we can see that it bisects here. So this starts at a vertex and bisects side MO. So RN is a median for that triangle. An altitude for MOR. So an altitude for MOR is going to be MQ again. Looks like that is the only segment that meets at a right angle, right? Now we need we did that one. Now we need a median for MQR. So MQR. MQR. Ooh, that's kind of fat. MQR. And remember, a median has to go from a vertex and has to bisect an opposite side. So MQR, we've got this segment right here. So this segment right here goes from angle Q to side MR, and you can see it bisects it here. So QS would be the median for triangle MQR. QS. Alright, is segment AB a median and altitude or neither? So remember, the median has to come from a vertex, and it has to be a bisector. And altitude has to come from a vertex and has to be perpendicular to the other side. So let's see what we got. Example 10 is AB, so we're always looking for AB. So the thing is, an altitude can be on the outside of a triangle, so that's kind of tricky. So AB is an altitude. It goes from the vertex of one vertex in the triangle, and it goes to the opposite side. It's perpendicular, rather, to the opposite side. So this is an altitude. So that's the tricky thing. It can be on the outside of the triangle. Let's go back and add that in your notes. And it can be outside the triangle. Alright, example 11. So AB, we're always looking at AB here. So AB. It does start at a vertex, but it neither bisects or is perpendicular to this opposite side. So this is neither. So what you should do is, probably should have paused, at least pause here and see if you can figure out the next two without me. Example 12, so we're still looking at AB, all the times we're looking at the same segment, AB. Now, is it a median, an altitude, or neither? So does it start at a vertex? Yes. Is it a bisector? Well, it doesn't give us any congruent marks, but it does show it's perpendicular to the other side, so this is an altitude again. And example 13, does it start at so AB is what we're looking at, AB. So, does it start in the vertex of one of the vertexes? Yes. Does it bisect the opposite side? So if it bisects, you're looking for congruent marks. Yes, it does. So this is a median. Oop, misspelled median. Alright guys, hope you're keeping up and having a good week. I think that's it.